Let's have a look at this question. It says a clock is such that it loses 15 minutes each day. That means 24 hours of actual time, it is going to lose 15 minutes. The clock is set right at 25th February 2008 at 2 p.m. So it is showing the correct time at that particular time. Approximately how many minutes should be added to get the right time when the clock shows 9 a.m. on 3rd March 2008. Now understand this thing, they are not talking about the actual time of 9 a.m. 3rd March 2008. They are talking about when the clock shows 9 a.m. 3rd March 2008, how many minutes should you add to this particular timing in order to get the correct time, or that is the actual time, right? That's what the question is talking about. So it is starting with 25th February 2008 and 2 p.m. So 26th February 2008 2 p.m. will be actual 24 hours and it would have lost 15 minutes. So if you look at this from 25th to 26, 27, 28, this will have 29 also, as it is a leap year, 1st and 2nd. I'm not going to 3rd March. I'm only going to 2nd March. Why? Because 3rd March complete 2 p.m. has not happened, right? So 2nd March 2008 2 p.m. So I'm looking at the actual time on what date? I'm looking at 2nd March and I'm looking at 2 p.m. This is the actual time. In this particular span of time from 25th February 2008 2 p.m. to 2nd March 2008 2 p.m. there is an actual timing of 6 days, right? Each day you are going to lose 15 minutes. So you would have lost how much? 6 times of 15, which is 90 minutes you would have lost. That means your clock reflection on that particular actual time will be what? It will be 90 minutes lesser than this. So you will be reflecting, the clock will be reflecting 12:30 p.m. on the 2nd March of 2008. This is what the reflection will be. Now the clock has to go all the way up to 9 a.m. The time on the clock should be 9 a.m. That means this particular clock need to look at 11 hours 30 minutes to go to the midnight, and then again take 9 more hours from there. So that's going to be 20 hours and 30 minutes more of travel. Now go back to the original data, 23 hours and 45 minutes when it happens on the clock, it would have actually lost what? It would have lost 15 minutes, correct? So this is the time on the clock when it travels 23 hours 45 minutes. It has actually lost 15 minutes. That is how you say in one day it has lost 15 minutes of time, correct? So 23 hours 45 minutes is basically 45 by 60 hours, which is 3/4 of an hour. Let's convert this into a fraction. 23 3 by 4 is what we are looking at. 4 3s are 12, 92, 95. 95 by 4 is what we are looking at. So in 95 by 4 hours of time on the clock, 95 by 4 hours of time on the clock, it will lose 15 minutes. That means 1 hour on the clock, it will lose 15 by 95 by 4 minutes, correct? And in 20 hours and 30 minutes, which is 21 by 2 hours, which is going to be what? 41 by 2 hours. In 41 by 2 hours time on the clock, how much amount of time will it lose? It will lose this much into 41 by 2. So if you solve this further, what are we going to get? 2 2s are 4, 5, 19, 3 over here. So this is going to be 6, 6, 246 divided by 19. It will lose this much. It has already lost 90 minutes and it is now losing 246 by 19 minutes. If you watch this very carefully, 247 will go into 19 13 times. 19 into 10 is what? 190 plus another 57 for 3 more times of 19. So that will give you 247, right? So approximately this value will be equals to 13 minutes. So 90 minutes you had lost earlier and you have lost 13 more minutes. So you have lost 103 minutes at the moment. If you add 103 minutes to this particular time, you will get to 103 minutes and you will get to the correct timing on the day.